Well, you know, the last question on that last video about this fuel pump situation here, the last question was, what are you going to do now, mechanic? So this is what I did. Problem being that the fuel pump is cast crooked. So I'm not sure who cast this fuel pump. I'm not sure who machined it. I know nothing about it. I just have to make this. That was the project, to use this fuel pump on that engine. It's a reproduction. And even now, it's no better now than it was. It's not good. What I'm saying. But to remedy the question, wasn't no question. It was a problem. So when I got this, it had this in here, and it was flat on top here with a hole in it that would go down in, and the spring rest on top of that. Okay, the spring could go to and fro, rubbing against the plunger in there. So I took it on to the lathe over there and counterbored that quite deeply to end up with, well, that's about, I'm gonna say it's 1/8 of an inch, but it's not. It's a little less than that. And it registers. Now when you put the plunger on there, the spring goes down in that and holds the spring in center. Also, when this was as long as this, and it was a good tight fit on this shaft, any degree of misalignment with the packing, or either this part here, would render this at an angle, and then once that angle was the distance of there, it was too much, so it would pull this up out of there. So now the distance of seat is this. It's loose like that, so it has a lot of misalignment and still be working. So we got that good to go. Also, by undercutting this by, it's about 1/2 inch, that gives me more packing in here like this. It'll be up here like that before it was down there. So this part's good to go. So, and the way I went about adjusting this fuel pump is, I took the original one and put the micrometer on it across this way. That's how thick this housing is. And it's on both ends the same amount. And it's a straight line back here. Okay, this one's already casted crooked, so, and it was the 1/8 of an inch offset this way, so I had to make it thinner that way. So I took the grinder to the seat here, this part, and the way that works is this bushing. This is your bolt coming out, that's your stud coming out. This bushing goes against that housing, and then when you put this washer on here, and your nut. When you assemble all this right here, write this down in that blank page. Okay, this right here it's captive. It can't turn. So that makes this cast iron hole here, that makes it a movable force onto this bushing, which is pretty good hard steel sometimes. And that renders this all mounted up fast and secure with the dowel pin to alignment and this to and fro. So that's the way that works. Now, the reason that this pump didn't work in this area is, and I couldn't remove the material on the back of it because it was it is too close to the engine already. So I had to remove the material off the front here. So if you put all this back together, I'll show you what we achieved by doing this. I could have put this housing in the mill over there and used a countersink spot drill and did it the same way. It would have just been a setup like that, and being there's no known point on this, but there's no reference point to it, so you just have to make it fit. It's that kind of situation. But now this whole mechanism is tight, and this whole mechanism is moved in this direction 1/8 of an inch. Okay, when I moved it over like that, it at that point lined up these ears here on this part. And I'll show you. If you come down like that, you have the equal amount of space on that plunger. Very good. That alleviated the problem also, as this exhaust push rod arm comes right in this area. Okay, when this come up like that, it would hit this. It was that much out of alignment. So we've got all this back together. Let's put some packing in there. Put them plunger balls in there. We'll get this back on that engine. Well, not to bring that into play, and keeping on subject here as it is. Noting that the size, you know, this stuff's kind of important, really. The opening right there is like 7/8. You know, that's a 7/8 hole right there. Well, on this reproduction, that hole's only, you know, you call it 5/8, but it's a little bit more. It's an oversized 5/8. So it's quite a bit of difference in the two sizes. And the reason that's important, this is the original packing that would be in that size hole. And take note that it is countersunk also. So the reason that's important is the seat area in there. The wider that seat is the better that packing will seal. Like this one right here don't have very much seat area in there. You know, it'll work, but it's not that good. Just saying. So with that in mind, we'll pack this pump. And this right here, that was about big around as your finger. You know, it was all braided up, and I took the time to unbraid that to get these little strands. That's about a foot long or a little more. It's good to work with this length on this size application. So to pack this pump is I use Teflon tape. I guess it's Teflon, I'm not sure. This one actually does have PTEE on there. I'm not sure what that is. And this one don't have nothing on it. But I find that the cheapest thread tape, thread sealant that you can get is the better, works better in this pump packing. And it don't dissolve in gasoline. If you going to type in a comment there that evaporates, it don't. You know, just put you some in some gas and test it yourself. But we'll get some oil.